In this video, I show you how to make this simple explosion effect in Blender using geometry nodes. As you can see, it is not anything physically accurate, but can be handy and not that difficult to create. This is the same effect I used in my previous video as well. First, I will create this sparks effect and then we move on creating the smoke one. So, let's start. I add a UV sphere. Go to edit mode and remove the bottom half of the sphere, which gives me this shape. I set the pivot point to 3D cursor and scale it down along the X and Y axis like this. Move it down a bit. Scale it down again and apply the scale. This shape will control the spark's initial distribution and their exploding direction. I rename this to Sparks Explosion. Go to Geometry Nodes workspace. My layout is probably different from yours, but you can drag from these corners to add or remove a window. Here I have Geometry Nodes Editor, Timeline, Properties Panel, Outliner, and Spreadsheet Editor. Let's start the effect by creating a new geometry node setup. I call it Sparks. This group output node will show us the final output geometry, and this group input node gives us the initial geometry, this shape. To create the sparks, first I need to distribute some points on this mesh surface. For that, I add distribute points on faces node and plug our group input node into this mesh socket and shift or click to plug this into group output. Because of our small shape, we only have one point, but you can increase this density to get more points. To make it easier, I drag from here and plug a multiply math node. Set the first value to something like 100. Then I can change the second value to get higher numbers for density easily. Right now these points are too big, so to see them clearly, I add a set point radius node and decrease the radius value. I do this only for visibility. Now I need to shoot these points or these particles out from the surface they are on. Here in this workspace, I disable the geometry node modifier and go to edit mode and enable this normals overlay option. These lines shows the normals of the faces. This is the direction I want the points to explode. Back in our geometry node setup, we do have access to those normals here. The points have inherited the normals of the faces. So, to shoot them out, I add a simulation zone into the setup. Inside this simulation zone, I can do geometry operation over and over on a loop. To access that normals data easily, I add a store attribute node here and store them. Normals is a vector value, so change this to vector and plug the normals into value. I call this normal. To displace any geometry inside geometry nodes, we can use set position node. I put it here. When I add a slight offset to the points on Z axis and play the animation, it adds that value over and over again in every frame, making these points go up. That's basically what this simulation zone does. It runs those operations over and over again every frame. To shoot them on the normals direction, I can access our stored normals using a name attribute node. Paste this name here. Change this to vector if it is not updated automatically. Now plug this to offset. You can see what it did in the first frame, and when I play the animation, it shoots out the points. It is too strong now, so to reduce it, I add a vector math scale node. This multiplies the whole vector by a given value. I set that to 0.1. But I like to randomize this pose. For that, I plug a multiply math node to here. For the first input, I plug a random value node. Set the first value to 0.3. This gives us a random value from 0.3 to 1 for each particle. Now this second value will control the overall strength. We can always come back to these values to fine-tune them, so let's move on to creating rest of the effect. I like to add some downward movement to the particles to mimic the gravity. I set it to a negative set value. I don't want them to go below the XY flow grid, so I add a position node. This gives us the current location of the points. Then I use a separate XYZ node to separate the vector values. Plug a compare greater than node to the set socket. Using this, we can mask out the points going below the flow. If the set position is greater than 0, this outputs true. I plug this into selection. This way, we are only adding gravity to the points that are above the ground. We can always mess with these values later. To further work on the effect, first we need to calculate the age of the particles. For that, I add a store attribute node and set it to integer. I call it age. Then add a name attribute and paste that name here. Add 1 to it using add_math node and plug that into store attribute. This is a simple method to calculate the age of the particles in frames. What this does is it looks at the current age value and add 1 to it, then store it as the new age value. Now to kill these particles after some time, I can add delete geometry node. I put it outside of the zone. You can put it inside the zone, but it will introduce us to a few issues in motion blur and particle IDs. We can fix them, but this tutorial will not be the best demonstration for it. I will make a video regarding that later. Anyway, to delete the particles, I access our age and check whether it is greater than or equal to, let's say, 20 frames. If so, I want to delete those particles. Plug this into selection. After 20 frames, they will get deleted. I want to randomize that as well. Plug a random value node. I set the min and max to 30 and 50. Now particles will get deleted when it reaches a random age between 30 and 50. To improve the effect even more, I duplicate this and store a new attribute called Normalised Age. It is a float. Here I want to map the particle's lifetime to 0 to 1 range. For that, I take age attribute and particle's maximum age. Plug a map range node to age and plug the maximum age to from max socket. Plug the output to normalize age. I can view it like this. It starts from almost 0, hence black, and then slowly reaches towards 1 or white and gets deleted. Now I can use this normalized age attribute to modify our force. For that, I add another multiply node. Plug a float curve node here. Adjust the curve like this. Plug that to multiply node. This way, at the start, particles will receive the full strength of the force and slowly reduce it to 0 when they reach death. And after that, it will be just gravity. Now, let's convert these points into something we can see in the render. For that, I add instance on points node. For the instance object, I add a mesh primitive icosphere. Although we use this radius for visibility purposes, we can put this into use. So I come here and search for radius node and plug that to scale. This will add that radius value to the instance's scale. To randomize that, plug a multiply node and random value node to it. Now, it has a random scale for each particle. If you want to change the overall scale, you can change it from here in the radius, or add another multiply node here and change it from here, like this. You can also mess with the shape to get different results, but make sure to adjust the point's density values after that. Right now, you can see the explosion starts right away at the first frame, but I want to control when it explodes. For that, I add a join jump node here and plug this into it. Now you can see it feeds these points every single frame into the simulation. We will use this method to create the smoke later, but for now, we only want these points to feed into the simulation for one frame. So I add a scene time node. This gives us the current frame of the animation. I drag from here and search for compare equal node. Set it to integer and plug this back. The frame I want to start the explosion is 10. I set it here. Drag from this and search for switch node. Plug our points into true socket. Keep the connections like this. This way it only lets these points pass into the simulation if this is true. You can see it starts at 10th frame. Let's add a material to this. I add a set material node. Create a new material, call it sparks and assign it to the setup. Now in the shading tab, I create a new window for the timeline. For the material, we don't need the principal node. What we need is an emission shader. To improve the material, we can use the attributes we created earlier. I copy this normalized age attribute name. Back in the shader editor, add an attribute node. Paste that name. It is not giving us that black to white gradient. The reason is that we are adding the material to instances. Those attributes will now exist in the instance domain. So to view them, you need to change this to instancer. Now you can see it is working. I plug a color ramp node here and adjust the colors for the sparks from birth to death. Plug it into the emission color. Also, I plug a map range node here. Flip these to make the output go from 1 to 0. Add a multiply node and plug that to its strength. Now, this will control the maximum emission strength. I add a plane to act as a flow. And also change the view transform to AGX. It is just better. And that is our basic sparks effect. Now it is all about tweaking the values. In the next part, I'll add some smoke and complete the effect. As usual, project files are available for Patreon members. See you in the next one.